Hello, everyone. Welcome to Time Travel Debugging Podcast. I am Dheeraj, the host of the podcast series. I'm a founder and one of the organizer of Indian C++ developer community, CPP India. CPP India is a community for C++ users by C++ users. I'm also a member of ISO C++ committee and representing India there. And I have been practicing software engineering for past 14 years and built various applications in IoT, PLM, automotive domain, etc. In my last 14 years of software development, I feel that I have spent more time in debugging than coding, whether it's completely new development or a maintenance project. It's my feeling that majority of developers spend more time in debugging. According to Undo, a regular developer spends 25 to 50% of its time while debugging rather than on innovation. By the way, Undo is a time travel debugger company with extensive experience in building software that can make developers' life easier and help organizations to save some money. There is another survey from University of Cambridge which states that developer spends nearly 50% of their time in debugging, and total estimated cost of debugging, which includes wages and other overheads, is approximately 312 12 billion US dollars per year, and that's a huge amount. Last night, I was reading one post on Reddit. It was someone asked that how much time you spend while debugging, and as I scrolled through the comments, to my surprise, almost everyone admitted that they spend more time in debugging than actually writing code. And one gentleman who was having more than 35 years of experience, he said, at least 99% of time I spend working on code is spent trying to fix problems, whatever that code has. So 99% of time, that's a huge. And another guy, he said that I have written about 20 lines maybe and spent 3 hours debugging them. So there were many more similar kind of stories in that thread, and on internet also you will find that. uh, these observations raise few questions in my mind. Are they not efficient or good developers? Why do they spend so much time in debugging? Or is there any way to improve the debugging experience and reduce debugging time? Because I don't feel that I mean, those people are not a good developer or not a good coder, but there is something missing, I feel. Let me know in comments if you miss how much time you spend while debugging. So we'll also have some stats how our audience feel how much time you spend. So in this LinkedIn Live podcast, which is time travel debugging, we'll be talking to different people from software industry in various domain and try to find answer of these questions. We'll also explore how debugging has evolved over the year because, uh, as per my knowledge, since we have started writing code, so debugging is since then it started. So how the approaches changed, we'll discuss that, and we'll find out the new approaches to improve debugging process, which enable us to spend more time in innovation than just fixing bugs. And this will be a monthly podcast. So follow me and Undo LinkedIn page to get a regular update. And now let's start our today's podcast. And let me introduce our guest. So we have today Ken with us. So Ken Skies is a principal software developer at Microsoft and going back to Windows 3.0, which was announced in 1990, and I was kid at that time. Yeah, and In his career, he has done lots of things. He has worked on Microsoft Paint, from chopping block and fixing key 16-bit memory limitation in Windows 95. Again, that was when I was, I think, somewhere sixth or seventh standard. And he has worked on Shell, Microsoft Shell, Ninja, and most recently, he's working on time travel debugging. And Ken is involved with time travel debugging in for I think since 2006. Debugging has always been a passion for Ken, and believes time travel debugging is an extremely powerful tool that should be in every developer's toolbox. And we'll discuss about that. What is his thought on that? Why he thinks like that? And when he's not doing anything, he loves to play golf. So, welcome, Ken. Welcome to this time travel debugging podcast.
Thank you for being here. Let me be here. Yeah.
Yeah. And we have another guest, Dr. Greg Law, with us. Greg is co-founder and CEO at Undo, and for last 12 years. Before founding Undo, he was a product manager for SolarFlare, and previously a software architect in NextWave. He is a well-known speaker in software community, and you can watch his talks on from CPPCon, CPP Now, or CPP India on YouTube. Thanks, Greg, for joining us today.
Hey, Dheeraj. Hey, Ken. It's great to be here.
Yeah. Okay, so let's start. And Ken, I would like to ask you first question, because you have started your software journey before I started learning. So, what is your experience in software development, and how do you see debugging over the years?
Sure. So I do have a pretty long history of software development as a professional. I've worked at Microsoft basically my entire adult life, and started writing a mix of assembly and C code, and graduated to C++, in the early to mid 90s, I'd say, in order to write COM objects, which are big in Windows. And then it wasn't until C++11 that I really sort of embraced C++ for real. Before that, things were just too much boilerplate for me. But lambdas, things like that, made it worth giving it a second look. As far as debugging goes, I've been a fan of debugging for a long time. I think in university, all the code you write is your own, and it's short, and printf debugging gets you by. It's fine. When you get into a software company, most of the code is not code you wrote, and you're writing a lot more code. It's much bigger, and so you need better tools in order to survive and to build production software. I used console debuggers, things kind of like GDB, although I've been on the Windows side most of my life. Even today with WinDBG, I tend to live in the command side of the window and peek at the source code. That's about the extent that I live there. But when I write things like like C#, I'm very happy to use Visual Studio's debugger.
I think that's a key point, actually, Ken. I'm really glad you said that about how if you know all of the code, right? If you wrote all the code, or perhaps you're on a team of 2 or 3 people and everybody knows every line of code, then you can. I mean, a lot of the times you can just think really hard and figure it out, right? Mm-hmm. I think it's related. It reminds me of there's been a bit of debate over the last. It seems to this question goes hot every few years, right? And it went hot again recently. Of like, should people use debuggers or not, right? And which I just think is a bizarre question in the first place, right? Because you just under the circumstances, and and it's a lot of people seem to come down like really hard binary on one side of the fence or the other. And one of the arguments people give, I mean, there's some strange arguments people give about why you shouldn't use debugging tools. One of the ones I find most bizarre is it makes programmers lazy. Right, I hear that a lot. Debuggers make programmers lazy, and I think do plows and tractors make farmers lazy?
Right.
You know, I mean, it's a
Well,
strange kind of position, but I think it makes a difference if you know all the code. That's one thing, but most of us are working on code bases that are millions of lines of code, and nobody knows.
And I think a problem starts when you have a team, means when you are going to collaborate and someone is writing based on their understanding, which may or may not be different than yours. So then it starts, I think, problem starts getting right.
yeah, I think it's interesting, lazy programmers. Like, I care a lot about efficiency of code. And when you have to step through at the assembly level code, you learn really quick. It's like, wow, this is a lot of code. This is horrible. And, I would tell people, if you don't like stepping through it, imagine how the processor feels stepping through it all day long.
Right.
So, yeah, debugging is a great tool. You learn, it's like you're blind until you open to the code and see it for real.
Yeah, right. Nobody knows what that code really does, right? Like even if you wrote it all, actually, it's not working in the way you think it is.
Yeah, I look at it as a source of truth.
Yeah.
So I think this also happens, means you wrote some code today, and after, let's say, 6 months, there is development going around your code base, and you don't know what is going to happen there, and you need some help from somewhere. So I feel that's not a right statement to say why we need debugger. But again, it's choice.
And I think people often, and also there's a bit of bee in my bonnet about people talk about debugging. People and sometimes they mean using a debugger, right? So people talk about like, does anyone do any debugging anymore? But for me, I mean, Dheeraj, you were touching on this earlier, right? Debugging is the process of understanding what the code really did, right? Which is like different from your expectations in some way. And you could be doing printf debugging, right? And printf debugging, like sometimes that's the best tool for the job. It all depends on what you're trying to figure out. If you want a kind of high level narrative of what the code did, then printf debugging is quite good. And when you first look at some kind of crash, whether it's I just typed a code and didn't work first time, maybe I got a bug report from production, like whatever, maybe it came from QA or something, or CI. The first thing pretty much everyone does is look at the log, right? You look at the logs and see if you can see. And like sometimes you on a good day, you've got enough information right there in the logs that you can deduce what went wrong and you can kind of put out a fix. And logging is, I consider to be the same thing as printf debugging, right? There's just these sort of statements of output that the program is telling you certain interesting things that it's doing, and that's everyone's first port of call. If that tells you what you need to know, great. But 90 whatever, I don't know, some large chunk of the time, there's not enough information, and you need more information to deduce what's actually happening. And that's where, like most of the time, most people just start hacking in more printfs, right? And I would think sometimes that's absolutely the best thing to be doing, but it's probably not the right thing most of the time.
And adding lots of log, printf, and that is also not good, because that loads your code, your binary, and you add lots of unwanted lines of code there.
Well, that's logging, thing, right? Well, do you check in? Do you check in those logging statements to source control, or do you kind of throw them away? But even if you're throwing them away, then so there are things you can do, and you can like conditionally compile and stuff. So I think there's stuff you can do with logging statements that don't bloat your code. So that I think you can deal with, right? But it doesn't change. I mean, the fundamental thing is I need to recompile, rerun, and like catch it again, right? And when you're debugging, I think it's almost always this process of like teasing out multiple clues one at a time, and I slowly build up the picture of like what actually is happening. And if every time I need a new clue, I need to run the program again, Well, and especially like if I'm working on a kind of bug where it's a deterministic thing and it always fails the same way every time, then it's annoying, but okay, I'll probably get there in the end. But a lot of times, bugs like race conditions and things, which just they change every time, right? And so by running it again, getting another clue, but now I'm getting another clue from like another, like I'm getting another clue from another murder scene, right? And then so trying to like piece together the story is just becomes just very inefficient.
Right. Yeah, it's fairly often developers will say that can't happen, right?
Yeah.
And it's like,
right.
And then with the right tools, you can find out, first it did happen. Now you understand why it happened.
Yeah. Absolutely. I'm always amazed at how, I mean, obviously, like Ken, you and I both have we both have a dog in this fight, so to speak, right? We both have, we're both biased, and we think that the time travel debuggers, but are super useful way to diagnose these. But actually, I don't care as much as I do about like use the tools that are out there, right? Developers should be using the tools that are available. They should know at least to a certain degree what the tools are, how they work, so they can pick the right tool for the job, right? And it's just I find it quite surprising how many otherwise good, competent professional developers really just don't know about the tool, and they're quickly dismiss. Oh yeah, I don't like this, don't like that. Have you ever used it? No, but I don't like it for this reason or that reason. Really?
Yeah, I mean, like a profiler is another common tool. It's like you don't profile with time travel debugging in most cases.
Right. So yeah, I mean, it's I mean, time travel debugging kind of is it gives you gives you the whole history, but yeah, you should, as a competent professional programmer, you should know the tools, and know how to use them, and that means have used them, and then make a judgment on whether I'm going to use this one or that one or no tool, or that's you've got to know what's available, I think.
Okay, so Greg, I have this question for you first, and then I will come to Ken. So based on your experience, what do you think, what are the major challenges software developer face? What kind of issues they get regularly, and what issues they face while debugging, based on your experience?
I mean, gosh, so many. I mean, yeah. I mean, I completely agree with what you said at the beginning. That the debugging basically dominates software development, right? Another way of kind of putting it is how many lines of code can you write and have it work first time, right? And like immodestly, I kind of think of myself as an okay programmer, but reality, like in practice, how many lines of code do I write and have it work first time? 10, maybe fewer. How many lines of code do I change of an existing code base and have it work first time? And I reckon that number averages to less than 1, right? It just and so it never works first time, and so you're trying to figure out, well, what actually happened, right? And the computer's doing probably billions of things every second, and there might be millions and millions of lines of code, and it's like the ultimate needle in a haystack challenge, right? If you kind of think of it in those terms, I mean, and humans humans just aren't very good at programming, right? It's not a very human thing to do, the level of kind of precision that you need. And then you just got this needle in a haystack challenge. So it's kind of quite surprising that we ever debug anything, actually. And I think as programmers, we just learn all these techniques and tricks, and whether we're learning the tools or not, we're certainly using techniques and tricks, and that's just a huge part of being a good programmer. And so it's the colossal amount of data, right? It's the size of that haystack that you're looking for the needle in. That's just such a challenge.
Right. I would say it's the scale of everything about professional development, because you don't write all the code, right? The customers are running the software in an environment that's not yours, right? And they'll tell you it's not working, and you'll say it works fine on my machine. And, it's the ecosystem of hardware is varied, right? So it works fine on my machine. Another machine has a different setup,
Yep.
It's not going to work.
Right.
And so,
right. And then depending on the customer, like sometimes you'll say, okay, well, can you give me some information about your system so I can try and think about what's different? And they say, oh no, I couldn't possibly tell you anything because it's like, confidentiality and
or if they're just wrong, like they tell you what they think the problem is, or what they think is related, and it's just not at all. And it's not their fault, really. It's just
And this is the common fight between developer and tester.
Right.
In every team, this kind of things happens. It's working on my machine, so what
works
should I
on my
do?
machine.
Yeah. Okay. So, Ken, you have been working with this time travel debugging thing, and you are a big advocate of that. So, how this can change a developer's life?
Yeah. So there's there's three use cases, but the two big ones. Number one is the works on my machine doesn't work on someone else's machine problem, right? Like our escalation engineers, they deal with customers, and every day they're collecting traces on customers' machines, and they're bringing them back to the engineers on our support team and to the engineers in the product team. And before time travel debugging, if a customer has a problem and you can't figure it out over the phone, you're on a plane to go and figure it out on site. And time travel debugging greatly reduces that problem, right? So, and even internally, someone reports a bug. If they tell you what they think is wrong, then you have to repro it. If they record it on their machine and they give you the trace file, now you have something that you can debug. And so it's just, once debugging becomes part of your regular workflow, you're happy to receive traces because it's just a normal part of your day. And the second thing is time travel debugging lets you fix that next layer of bugs, right? There's like the obvious bugs you just kind of figure out in 10 different ways, but then there's that next layer where it's like, oh, this memory gets corrupted, or things that can't happen do happen. And so you get that next layer of quality in your products by using it.
So is this helpful in those scenarios where sometimes what happens, your release binary is having some error, but when developer is developing and that debug binary, that might not you are not getting that error in that environment. So that in that scenario, is that helpful?
Oh, for sure. I mean, it can be simple things like there's a space in the path, and there's a bug in the code where it doesn't expect a space in the path, right? And on your machine, it's like all my paths have no spaces, and so everything's great. And so yes, it's very reassuring to know that if you capture something with a recording, you capture a problem, that the answer's almost always in there somewhere. You just have to dig it out.
For me, it's that visible. I mean, it strikes me. We should probably just say very briefly what time travel debugging is, just in case anybody listening isn't familiar with it. But because it's still actually quite, in my experience, not super well kind of known and not super widely used still, despite how powerful it is. And I think just what you said, Ken, really. But it gives you a recording or trace of everything that the program did, like everything, like any line of you can wind the clock back to any line of code that executed, and you can see complete kind of program state for every single line of code that executed. So you've got full visibility into exactly what happened, and so it completely demystifies this needle in a haystack problem. And then with that comes these other added benefits that you can take what we call a recording file. I think what Microsoft calls a trace file, basically the same thing. You can take these recordings and they're portable, right? You can take it from the customer machine or from the production environment and load it up on your local development environment and see what it saw. Right? You don't need so you get sort of both the visibility into what happened and it's not that you can reproduce it as much as you no longer need to reproduce it. Right? You just need to reproduce it once, and then sort of as I was saying earlier, that you're kind of going through this process of getting one clue at a time and slowly building up this picture. you do that with just one execution of the program, right? And if you're in, I sometimes say there are two things that make bugs difficult. One is how long elapses between the bug itself and you noticing, right? The program crashing or incorrect results or the assertion firing. And obviously, the longer that time is, the harder it is to debug. By the way, that's why assertions are so powerful, right? Because they narrow that window as much as possible. And then the other kind of dimension to it is how deterministic is it, right? Does it occur in different range time? And so time travel gives you that ability to just record it once and then over, you can take as long as you want to see exactly what happened, line by line. And it's amazing how often it's not, even when you don't consider there to be a bug, it turns out the code's not quite doing what you thought it did, right? And that might be a performance issue that you alluded to earlier, Ken, or it might be actually there is a bug here, but we didn't have a test yet, but that's waiting to blow up or whatever.
Yeah. So means there happens sometimes as Ken mentioned that there may be some use case when you are that error will get hit, that bug will get hit, and but you cannot reproduce this every time. So in those kind of intermittent bugs, this time travel debugging will be very useful to right?
Yeah.
So
to be fair, just to sort of give a full account of it, of course, the kind of one downside of it really is you do have to capture the bug in the recording, right? And as opposed to particularly static analysis tools, which can give you some kind of information about what the program might do, not necessarily what it did, right? And again, pros and cons, different tools. I mean, nearly all of our customers also use one of the leading, at least one of the leading static analysis solutions, so that they because you kind of want both. You kind of want to know what might happen and exactly what did happen.
Right.
Yeah.
I was going to add one more point about the portability, is that you can pass this file among multiple people, right? Like you take it to, in our case, say an escalation engineer, and they partly figure it out, and then but they don't fully understand it. They can give it to the product team, and they can pick it up from there. And maybe they still don't understand it, and they give it to some expert in the company, and they're passing along their notes and the locations in the trace as well, so that you're not starting from zero each time. You're just keep honing in on the problem.
Yeah, that collaboration side of it. I think if you look at if you look at most hard bugs, whether you're looking in like the GitHub history or the Jira ticket, or however you're managing these bugs, you often find many developers contributing comments in the history of working together collaboratively to, oh well, it actually might be this thing, oh yeah, that's a red herring, that's supposed to work that way. And if you can pass around the recording, then it's so much easier to do that level of collaboration.
Right. So when we are talking, both of you mentioned this recording thing, which we can replay afterward. So I am just wondering what actually happens in that recording behind the scene. Is what actually it records. Ken, would you like to go first? Yeah.
Wait, you want me to go first?
Yeah. Go ahead.
Okay. All right. So yeah, it is a complicated technology, but there's some fundamental pieces to it. At its core, it's a CPU emulator. And so TTD has an emulator that decodes instructions from the CPU, turns them into instructions in our imaginary CPU emulator, and then we write out into the trace file. Basically, conceptually, it's the inputs and outputs of every instruction. But obviously, that would be a tremendous amount of information, and it's unnecessary. So what we do is we only write down the things that we can't predict. And so, if you start with the initial register state, right, and you just run along until you read a piece of memory, we only have to write down the initial state. And then when you read a piece of memory, we have to write down, this that we read this value, right? Or certain non-deterministic things like we ask the CPU to generate a random number generator. We have to write that down. And so we do that and write out to the trace file, and we do this. Each thread records independently, and then we have a way of ordering, knowing logical orderings between threads, like, this thread did an atomic operation at this point, or this thread went to kernel. And yeah, and then on the replace side, so on the record side, it actually has to do all the things that your CPU wants to do. If you want to write to memory, it needs to write to memory. But on the replay side, you don't want to do all those effects, right? You don't want to be creating files when you replay, for instance. And so the emulator, there's one mode of the emulator that's basically read-only versus read-write. So that's kind of the first layer of it.
Okay. So is it some kind of sandbox you create?
No, it injects itself into the target process and gains control of the machine, and then it will walk through the code, and then you go out to kernel, you come back, and it picks up where it left off. So our product only records user mode code. It doesn't record the kernel mode side. And yeah, so it's just running inside the process.
Okay. So Greg, in undo have one tool that UDB. Are you also following same kind of strategy in that, or something?
Yeah, it's similar. It's similar because you get the fundamental kind of observation that if you, as I said before, if you have the effect that you've recorded every single line of code that executed, and for the full program state for every line of code that executes. So clearly you can't record all of that. It'd be way too expensive, and you can't even, as Ken was saying, you can't even record like just the differences of each instruction. You can, but it's just really expensive to do that. And so, yeah, the kind of significant difference between undo live recorder or UDB and TTD is the kind of the big single difference is that we don't record all of the memory reads. We rely on the fact that memory is actually is itself kind of quite predictable. Now there are important caveats to that. Sometimes the memory might be shared with another thread or with the system or with another process. So you can't rely on the memory being predictable, but I think sort of architecturally it's a little easier in Linux to predict which bits of memory might change under your feet and which won't. So it gives, but the basic design philosophy kind of, it's like any kind of design choice, there's trade-offs, right? And so I think the Microsoft TDD approach will, the biggest single win for that, I think, is you can record multiple threads genuinely running at the same time, right? And that's a big win compared to our approach, where we have to kind of, to some degree at least, serialize those threads' execution. But the win of doing it our way is that the recording files, trace files, tend to be much smaller, because we only have to record basically if it's like system I/O or shared memory, shared with asynchronously written memory or something, and we have kind of ways to do that. So we're recording less, and the per thread slowdown I think is usually a lot lower. But the caveat is you kind of have to serialize all the threads to do that, because one of the big causes of non-determinism or unpredictability is thread interactions. So, but it's still, I mean, if there's any doubt, I mean, it still works perfectly well with multi-threaded code. Nearly all race conditions will reproduce in this still. So something people often hear is, well, you're serializing all the threads, so therefore my race conditions are going to go away. And it's like, no, that's not true. Like we still will stop threads at any point and allow other threads to run. In fact, we have stuff to deliberately provoke that. Like, so we'll notice that this is an atomic, locked instruction. So this is probably a good time to pause this thread and let another thread run for a while. And so the only exception is like if you have if the race is a race condition due to a missing memory barrier, they will get this. worth of recording. You just can't reproduce those with our technology, with this approach, at least not today. But everything else will reproduce. It might take a shorter or longer amount of time. And then just, exactly the same with the Microsoft and the Linux versions. Once you've captured it, then it becomes usually pretty straightforward to debug. Actually, most of the time it's like even the most gnarly, difficult race condition is just kind of served up to you as a developer, served up on a plate.
Yeah.
So
I do want to say we do have a memory predictor as well.
Oh, you do as well. Okay.
I was being, I'm not quite sure how deep do I go in these descriptions, but yes, we do have a memory predictor. But I agree. You're right that if you serialize the threads, your predictability improves a lot, and that helps your file size. That makes sense.
Yeah.
So means these tools are doing lots of heavy lifting work behind the scene, which will ease a developer's life. So I have one question, because I got this technique is pretty old. I think at least 10 years. It's but no one is talking about that. And what I feel is, most of the time it is a mindset in developers and senior developers and everyone in industry so far, that debugging is a skill, and a good developer should be very good in debugging. He or she should have a good debugging skill, and if that person is skilled, I don't need any debugging tool. So that kind, and that too, if it is a paid or something, if there is some licensing involved. So people usually avoid and they don't talk about those kind of things. So what do you think, how correct it is? Should we consider it as just as a skill and judge developer based on that? Okay, if someone says I need this tool, so should we judge that person, or it's just okay, it's a tool?
It just goes back to what I was saying earlier. I just find it strange. Mindset. I agree that mindset is out there in some places, and it's like, it's what separates humans from the animals, right? I mean, using the tools and being able to use tools effectively makes you better at your job. And it's just although you did touch on something that's interesting, is if you have to pay for the tools, I have to say, I think there's a certain maturing of the industry that's happened over the last, say, 10 years, where back when we were starting out, there was definitely, and particularly, we work on Linux programs, and particularly in the Linux space, there was kind of a pride, and I used to joke that developer tools were kind of developers' versions of sex, in that if you have to pay for it, then there's some kind of shame associated with it. And I think there's a certain kind of, we've matured a bit there, and people actually will, have accepted that, no, you can, there's some tools you can get for free and they're really good, right? And there are other tools that you can pay for that do things that, that you can't get for free. And there's a much more willingness now, I think, things like, GitHub is perhaps very well known one. JetBrains doing very well. There's lots of tooling on Linux that people will now happily pay for, as long as they're clear that they're getting value for that, right? Yeah, sure, you wouldn't pay for something if you can get something that's just as good or even nearly as good for free, and why would you pay good money for that? So that, I think it's maturing, but no doubt there's still some of that, still some of that philosophy out there. Like, I think not so much I shouldn't use the tools, but I shouldn't have to pay for anything. I should be able to download it all and build it myself. Otherwise, it's like some kind of failure.
Okay.
Right.
So Ken, what do you think? How is this mindset still, or this mindset is going to change?
Yeah. So as far as developer psychology goes, I think developers are optimists and they're prideful. And so it's like, first, we don't write bad code. And second, if we do, we'll figure it out quickly. And third, if I just restart it one more time, I'm going to figure it out this time. Right.
One more printf.
Just one more printf, and I got this. I don't need that tool. I think cost of tooling is in multiple dimensions. I mean, Greg's talking mostly about price, but there's the cost of setting it up. There's the cost of running it. Anything that creates friction in the process right, is a problem. So if like the least friction is when someone assigns you a bug and there's already a recording in the bug, and all you got to do is open it and figure it out, right? So yeah, and occasionally, I mean, obviously, file size can become and slowdown of recording of the process can be a problem at times, right? So like those race conditions, sometimes they're tight windows, and you won't see it crash the way it does, you know, when it's running live. So yeah, I think it's about integrating the tools and making it like the default thing. It is the cost reduction that'll get it used more.
A lot of so much habit and anxiety kind of gets in the way. But it just kind of I mean, actually, if I Dira, do you mind if I ask Ken a question? I'd love to get your take on this. So we talked a bit about how like time travel debugging is like completely awesome, and like okay, it's not like everything, it's got places where it's really effective and maybe less so, but overall really powerful, really useful thing. So how come like not everyone is using it? Right? Why isn't everybody using time travel debugging by now?
Right. Well, my opinion is, again, there's the developer psychology, right? If I build my program and I run it in, say, Visual Studio, right? If time travel debugging happened there by default, everyone would be using it, but it doesn't, right? And in fact, we're not integrated into Visual Studio at all today. And I think that would be the number one way to increase usability on the Windows side.
It's a friction of getting started.
Friction of getting started, yes.
And what I feel is sometimes it's driven from organization. Developers want to use some such tools, but because it's an organization driven thing, so that also blocks, because using a tool, that to a paid tool, will not show you immediate benefit in short term, but eventually it actually saves you lots of time. And we say time is money, and time converts to money. But so in a little long run, it will eventually help you, but in a short run it don't show any immediate benefit, which I feel. So that's why maybe organizations are little hesitate in spending some money on
but I mean, our tool is not free, but a lot of tools TTD is still free, right? I can download it and use it.
It's still free.
I don't have to pay anything for a license fee. On the Linux side, there's RR that you can download and use for free, right? I mean, you can't use it everywhere, but where you can use it, it's just free. And so it's like it's there's something else, and even I have to say, even like when we are well established within a customer and we're installed across their in their network, and it's just there for the engineers to use, and we have some proportion of the engineers just use it like all the time, and it's and there's just and a lot either they don't or they take a long time to adopt it, right? And we can definitely we see very clearly from our user stats that it's super sticky. Like once someone starts, but just many years ago now, but I met a happy customer. It's the first time I'd met him. He'd been a customer for a while, and he greeted me with he said, "Man, I've got to tell you, your stuff is like heroin." And it took me a little while to kind of process that and work out what he was saying. But and I don't think he meant it ruined your life. But anyway, and you can just see it in the usage stats. Once someone becomes a user, they are just, maybe that's why we call them a user.
Yeah.
Like they're completely like stuck, but it takes them a really it takes many developers a really long time to get started.
I think the difference is it's like once it's saved your butt once, then you're hooked, right? And then you're going to that it'll fix it. It's like, let's say your product can't ship because you have this bug late in the game, and time travel debugging helps you fix that. If people know about it, right, that builds a culture, right? Because another thing is, like, if I use TTD and I fix something and I don't tell anybody about it, and how are they going to know that they should be using it as well.
Yeah, so I think that awareness is not that much, which this technique should get that people should talk about that and know about what it is and what problems it can solve. So I think for that we have this podcast series. So we'll talk about that and we'll let everyone know. Yeah. Okay, so now I have a quick rapid fire things. So I will ask one by one. Uh, you guys, I will give you one word, and you just let us know your immediate thought, what it is. So maybe Greg, I will start with you. Your first word is programming.
Programming, really hard. It's just really difficult to do well.
Okay. Ken.
Turning business problems into something a computer can solve.
Okay. Next is bug. Greg.
Bug is what really happened as opposed to what you thought was going to happen.
The bane of a developer's existence.
Yeah, right. And the essence of a developer's existence.
The essence of a developer's existence, yes.
I mean, actually, that's sorry, just to go off on a little aside here. I mean, that may be, it does strike me that may be part of the thing. If you like programming, to become a professional programmer, you must like programming. So to some degree, if you like programming, you have to like debugging, right? Because that's what you spend all the time doing. And maybe that's a bit of a challenge for us as well.
And someone told me if there is a bug, it means something is building.
If there's a bug, it means...
So if there is a bug, means someone is doing something.
Right. It's being used,
Because there is ideally no bug-free software. So it means something is happening there. Yeah.
Absolutely, No bug reports if no one's running the product. Right?
Okay, next word is debugging. Greg.
So debugging is the process of figuring out where, if the bug is, I've got two answers to this. Right? So the fuller answer is if the bug is where reality diverging from expectations, then debugging is figuring out where that point of divergence is. Right? Where did the thing start doing differently than expected? The pithier answer is there's two parts to programming. There's bugging and debugging. There's typing the code in and there's making it work.
Ken.
That's pretty good. I have to follow that. I think debugging, the problem with computers is you have to fully specify everything, and debugging is realizing all the things you didn't specify well enough. And occasionally there's logic errors too, where it's just like you just weren't thinking about it right. But I'd say for professional developers, it's not thinking about all the scenarios or the interactions between them.
Okay. So next word is productivity.
Ken, why don't you go first? I've been going first.
All right. So productivity is making efficient use of your time by letting the computer, which is very fast, do as much as possible for you, right? So automation, tooling, static analysis was a great example earlier. Anything that the computer can do, it'll do faster than you. So.
Yeah, I mean, maybe you could sort of slightly generalize it to using technology to get more done for the same amount of investment or input, right? And so that might be that you're a farmer plowing the field, right? That's using technology to become more productive. I often hear one of the early, you don't usually hear this after a while, but one of the early kind of complaints or objections to this you get, the time travel debugging you get as well, is overhead involved in recording the program, right? It's going to slow down, and my program runs for a long time, and I don't know if I want to wait a few hours because it normally runs in 1 hour, now I have to wait for 2 or whatever. And I'm always like, compute time is cheap, right? Compute time is cheap. Human time is expensive.
Yeah, definitely.
Yeah. Okay. So next is developer efficiency. Ken.
I was kind of answering that question similar to productivity. Yeah. But yeah, I think you know, developers have a dream. There's like you know, the memes about this is what you think developers do versus what they actually do. And so the more that you're doing the dream side of like I'm writing code and I'm figuring out things, right? I think you're more efficient. When it's like trying to get all the stuff you already wrote to work is being inefficient. So minimizing that time.
Actually, I'm going to give a non-time travel debugging answer here, actually, a non-debugging answer even. And actually probably the most important thing for developer efficiency is to not waste time building the wrong thing. There's a saying, I think it's Paul Graham, that the hard thing about programming isn't writing the program, isn't solving the problem, it's choosing the right problem to solve. And so, you know, that's probably the single most important thing that will determine the efficiency and the productivity. But then I'm going to say, once you've done that, once you're confident you're working on the right problem, yeah, getting the bugs out is just the biggest lever you've got.
Okay, so I had these words, and because we are about to end off the time, so I have one last question for both of you. Uh, what suggestion you will give to our viewers, so how they can improve their debugging skills? Ken, would you like to go?
Okay. First, use it. I mean, there's a lot of data that says people are not using the debugger enough. And so dive in and use it. And look for people who are experts at debugging and learn from them. You know, like we're fortunate we have ProgrammingGyan working for us, and he's a master debugger. And he's, if you read his old new thing, you learn all kinds of things. I think debugging is one of the topics there. And certainly internally, he's always showing us how to take a dump file or something and extract out what happened from the wreckage that is a dump file. So.
I think that there's actually I did a talk about this when I was in New York last week, so it's just kind of fresh in my mind. And I think you know, I've already said it. I'll say it once again. You know, like absolutely know the tools that are there and use the tools. But it's not just about tooling, right? I think there's a lot that, you know, for debugging. I think actually, if you'll excuse the awful pun, step back. Right, take a step back, but not just like stepping backwards in the debugger, but stepping back from the problem. I think we've probably all been there when you know, you're just working on something all day, like your mind is frazzled. You've got, like what Ken was saying, that sort of optimism, like I'm nearly there. I'm just going to like one more go, and then I can, like, you know, finish up and go home. And then eventually, you know, just it's like now getting far too late. I'm going to get in terrible trouble with my family back home if I don't get home right now, or something. And so then, okay, right, I'll go home. And then, like, sometimes literally before leaving the building, the answer presents itself, right? Or maybe it's in the shower the next morning, you know, the answer presents itself, or out, you know, walking the dog or something. And you know, thinking about, sometimes you get in a rut and you're thinking about the problem so hard that you kind of miss the obvious. And it's often like you know, like these kind of Sherlock Holmes kind of mystery kind of stories where, like, the answer actually was staring you in the face all the time, but you just didn't see it, right? And so, you know, taking a step back. And one technique I like is writing down what you think you're seeing, like with pen and paper. I think this is like not typing it in, because most of us as programmers, we can type way quicker than we can write. So if you write it down with pen and paper, like that forces a kind of it forces you to write slowly, right? And so it forces you to think harder about every word. And so often I'd find myself, you know, I'd write down, okay, what I'm seeing is clearly completely impossible. There's no way that, you know, I can be 0 when, you know, J is negative, and because we check that before, and then you go, oh, actually, do we always? Maybe there's and just writing down what you think you're seeing teases out the bad assumption. I think so often bugs are, I mean, perhaps maybe by some definition always due to basically a bad assumption somewhere along the way. And you know, the thing about an assumption is you don't realize you've made it, right? And so that process of writing it down is kind of a solo version of the rubber duck debugging. Probably a lot of people have heard of this, right? It comes from a professor, I think, who was teaching students to program, and he got sick of, they'd say, I'm completely stuck. I've been working on the problem for an hour. And before they'd finished explaining the problem to him, I realized the answer now, right? Because the process of explaining made it obvious. So he put a rubber duck in the corner of the lab and said, explain the problem to the duck. And then if you still don't have the answer, then you can come and ask me. And so writing it down on paper is kind of that slightly less awkward version of it than talking to a plastic animal.
I wholeheartedly approve of writing things down.
Yeah.
Good advice.
With pen, get a good quality pen as well. That really helps. Like a nice pen that makes the writing kind of
To do that kind of tough job, you need at least some good tools.
Yeah, exactly, right. Use the right tools. Exactly.
Yeah.
That's right. A cheap tablet.
Okay, so that brings to the, I think, end of our conversation. Actually, I was liking this discussion. I want to continue this, but it's almost we covered the time which we blocked, so we'll have to stop here. And I request all our audience to try it, time travel debugging, explore it. It will definitely help you. And I started exploring this for last 10 or 11 months, and to be very honest, I am really liking it, and it helps you to find your work very fast. And this podcast will be happening every month, so follow undo page and follow me or follow Greg. So you will get regular updates on the next episode.
Sure. Just before we wrap, I just know that if we've got just for time very quickly, I noticed a question in the comments that I think probably is aimed more at Ken. Of like, does TTD work with antivirus installed, or does the AV prevent you injecting the code you need?
Great question. I would say it works with Defender, and it works with some AV software, and like some AV software blocks it outright, and others you can add an exception of some type to allow it to run. But yeah, it's third-party AV software is a problem for us.
Yeah, I mean, probably little less relevant on Linux. Although I suppose the equivalent is something like SC Linux, which again, if you really lock down your SC Linux config, that can get in the way. I think generally it's if you can attach a debugger, then if you can attach GDB or whatever, then you can make a recording using that stuff. But if your system is like sufficiently locked down that you can't do that, then it's like, because that's what these systems is kind of. It's a level of visibility these systems are kind of designed to prevent, right? So
absolutely.